This is Catherine Nightingale at Chattanooga State Community College, and this video is for Math 2110, which is Calculus 3, Section 11.4 on the triple scalar product and torque. These are two applications of the cross product, which we discussed in the previous video, and we'll be going over how to apply these to find volume and force. The triple scalar product, also known as the box product, is defined as U cross V dotted with W. It can be used to determine the volume of a parallelepiped in 3 dimensions. So if you look at this picture here, we basically have the area of the base of the parallelepiped is the magnitude of U cross V, and the height is going to be the magnitude of W times the absolute value of cosine theta, where theta is the angle between W and U cross V. So we end up with the volume is the area of the base times the height, which is the magnitude of U cross V times magnitude of W times absolute value of cosine theta, which can just be looked at as the magnitude of the triple scalar product. Now, as a determinant, the triple scalar product is defined as the determinant of the matrix with vector U as the top row, vector V as the second row, and vector W as the third row. Let's look at this in application to find the volume of a parallelepiped. Example 3 asks us to find the volume of the parallelepiped, or box, determined by vectors u, v, and w, where u is I plus 2j, v is negative 3j plus 2k, and w is 3i minus 4j plus 5k. Now the volume we were shown on the last slide is the magnitude of u cross v dotted with W. So what we want to do is take the determinant of the matrix with U in the top row, V in the second row, W in the third row. So that's U, V, and W. Now the next thing we want to do is expand along the top row in taking the determinant. So we take that first entry and then the 2 by 2 matrix left over by eliminating the row and column that the first entry is in. So we get 1 times negative 3, 2, negative 4, 5. And now remember that your signs alternate. You have positive, negative, positive across the top row. So now I'm going to do minus 2 and then the 0, 3, and 2, 5 columns, because that's what's left over when I eliminate the second column first row. So I have minus 2, 0, 2, 3, 5. And now the last one is a 0. So I'll go ahead and do plus 0 times the 2 by 2 matrix. Okay, now determinant of a 2 by 2, remember we go down the first diagonal and minus the backwards diagonal. So I'll have 1 times negative 3, 5, minus 2 times negative 4, minus 2 times 0 times 5, minus 2 times 3. And then the last part will just be 0. So you can leave that off if you end up with this situation in one of your homework problems. Now we simplify, that's negative 7 plus 12, which gives us 5 cubic units. Remember, we're dealing with volume, so it's going to be cubic units. And just make a note to yourself that you always take the absolute value when you're dealing with volume. It wouldn't make sense to have negative volume. Okay, so that is one application of the cross product and dot product, is that triple scalar product to find volume. Now one implication of this is that if the triple scalar product equals 0, then u, v, and w all lie in the same plane. Now, we'll discuss this a little further in class, but I'd like you to think about why this would be the case. There are two possibilities having to do with the geometry of that triple scalar product. So the first one is the angles. Think about what angle does u cross v make with both u and v? And then think about if the dot product is 0, what angle is made between the cross product of u and v with the vector w? So think about the angles involved in the cross and dot product. The next way you can think about this implication is as the volume, because we know that the absolute value of this is the volume of a parallelepiped. What happens if the volume is 0? So think about the triple scalar product. As I said, we'll discuss a little further in class, but that's something for you to think about in the meantime. Okay, now another application of the cross product is torque. And from the textbook we have, when we turn a bolt by applying a force to a wrench, we produce a torque that causes the bolt to rotate. The torque vector points in the direction of the axis of the bolt. You can see in the picture here your torque vector is the pink or red vector in the direction of the bolt, and describes the tendency of the force F to drive the bolt forward. So you're turning the bolt and it's being driven forward into whatever you are building. The magnitude of the torque depends on how far out on the wrench the force is applied and on how much of the force is perpendicular to the wrench at the point of application. Now if you look at the diagram, you have R as the length between the center of the bolt and how far out on the wrench you're applying the force. And then we're really interested in the downward or 90-degree angle component of the force. So the force that makes a 90-degree angle with R. And if we think about the angle that your force makes with the wrench, then the component of F perpendicular to R is going to be the magnitude of F times sine theta. So it's right triangle trigonometry. So what happens is we want the length of R times the magnitude of the force that's perpendicular to R, which is magnitude of force times sine theta. So if R is the length of the lever arm, then magnitude of the torque vector is magnitude of R times magnitude of force times sine theta, where theta is the angle that your force makes with the wrench. And just make a note that this is actually the magnitude of the cross product, R cross F. So it's an application of the cross product. Now our last example has us apply this torque definition. So we have example 4. Suppose you apply a force of 30 pounds to an 8-inch long wrench attached to a bolt in a direction perpendicular to the bolt. Determine the magnitude of the torque when the force is applied at an angle of 60 degrees to the wrench, and answer in foot-pounds. Okay, so here's my bolt, and there's the wrench that we're going to apply the force to. We have R is 8 inches, so from the center of the bolt out to the end of the wrench where the force is being applied. We have this force being applied at an angle of 60 degrees to the wrench, and we know that the force or magnitude of the force is 30 pounds. So we're pulling down on the end of the wrench with 30 pounds at an angle of 60 degrees. What we want is this force that makes a perpendicular angle with the wrench. And so we can form our right triangle, and you can see that if 30 pounds is the magnitude of F, then this downward force, or 90-degree angle force, would be magnitude of F times sine 60. So now the magnitude of the torque, we're going to use the formula. First of all, we need R to be in feet because we want foot-pounds. So I'll do 8 inches times 1 foot over 12 inches. Gives me 2/3 of a foot. So I'll have magnitude of R, magnitude of F, times sine theta. So 2/3 of a foot times 30 pounds times sine 60 equals 20 times square root of 3 over 2. So I get 10 square root of 3, or 17.32 foot-pounds. And that's how we apply our torque formula to figure out how much torque is being applied to the bolt when we have a force of 30 pounds at 60 degrees to the wrench and an 8-inch long wrench. Now in class we'll be doing an exploratory activity, getting more in depth with torque and with the triple scalar product. So make sure you understand the basics from this video, and we'll discuss at the beginning of class before we begin our activity.